I've got a function up here on the board. F of x is 1 over x, and I've drawn us the graph of this function. So I've got two questions. First of all, I want to know, is this function continuous at 0? And then I want to know, is it continuous on its domain? So what I want you to do is just take a moment, pause the video, answer those two questions, and then tune back in. So our first question here was, is f of x continuous at 0? No, it is not. For several reasons. First of all, 0 isn't in the domain. I can't plug in 0. So there's no way that I can get what I expect because I don't get anything. Okay. Now it's also the case here that the two-sided limit doesn't exist. And I can see that actually we're going off to infinity from the right and negative infinity from the left. So we've got an infinite discontinuity here. Should just point out, this doesn't qualify as a jump discontinuity. Even though we do sort of jump a little bit, a jump discontinuity is when you're jumping from a finite height to a different finite height. If you've got a vertical asymptote involved, it's an infinite discontinuity. Okay, now the second question is f of x continuous on its domain? That's a yes. Now sometimes students want to say, but wait a minute, if it's not continuous at 0, how can it be continuous on its domain? Well, the answer is that 0 is not in the domain. So it can be discontinuous at a point and still be continuous on its domain if that point is not in the domain. Okay. So this is an important example because sometimes people give an incorrect informal definition of continuity. They say a function is continuous if you can draw it without lifting your marker from the board. Now, it certainly is true that if I can draw a function without lifting my marker from the board, the function that I drew will be continuous. But here's an example of something where I cannot draw this graph without lifting my marker up to jump from this piece to this piece, but it's still continuous on its domain. And that's because the location where I have to lift the marker to move to the other piece is a point that's not in the domain of the function. All right.